Okay, let's talk about transformations or some kind of ways that we can use what we know about graphs and kind of figure out what they're going to look like before we ever really have to pick up our calculator. Okay, now the key to this is that you have to always start with a principal function. Basically, what I mean by that is one of those library of functions. So if you'll remember from previous lessons where we've done things like the absolute value function, we did the square function, the square root function, all of those. That's what I'm talking about when I say the library of functions. We're going to start with one of those as our principal function, and then we're going to do things to it. And by what we add or subtract and in what the position that we do that, that's going to affect how the graph ultimately looks. Okay, first of all, let's look at vertical shifts. Now we have our formal definition here for vertical shifts. It says if you've got, basically if you're adding a value to the end of a function, then what this does is it shifts the function up this many units, however much it is. If we are subtracting something from the end of a function, we have a vertical shift down so many units. So let's look and see what we're talking about when we say that. Okay, here I have drawn for us, this is our principal function, our base function of x squared. This is our square function. And if you'll notice, we have some nice points here, and I got those by basically just plugging into the equation. We have this nice point here of 0, 0, and then 1, 1, and then we have the point 2, 4, and the point 3, 9. And again, we get those from the function. If we plug in an x of 3, we square that to get the y value, which would be 9. Okay, now according to our definitions, if we were going to take that original base function of x squared and we were going to add something to the end, let's add 2, then this says that will vertically shift or shift it up however many units. So since we're using 2, this is going to shift this up 2 units. It's basically going to take each one of these points and just raise them up by 2 units in each one. So I'm going to draw that in kind of quickly there. 1, 2, 1, 2, and then so on and so forth. So now this would be, oops, I'm off there a little bit. This would be the graph of f of x equals x squared plus 2. Now, we could also subtract something to the end of our function. So what if, again, we started with our base function, our principal function of f of x equals x squared, and this time we subtracted 2. Well, according again to our definition, it says if you subtract k units, that causes a vertical shift down k units. So I would expect to take my x squared function and drop each point down by 2 units. So now my points will be down 2 units. So this one would be down 2 units, and this one would be down 2 units. Each one of those. So this is what the graph of f of x equals x squared minus 2 would look like. And this works for any of the library of functions. I just chose the x squared to start with. I could have started with a square root function or a cube function or anything, and it works the exact same way. So by understanding the translations, and if you already know what the library of function looks like, then you can take those graphs and just move them up or down vertically to create that shift.